everyone's having a great day at Fyne Conference 2024 so far. My name is Renaldi, and today I'll be bringing you through my talk, Dynamic Data Visualization with Fyne and Go, Creating Interactive Dashboards. So without further ado, let's jump right in. So, a bit about myself. I am a software engineer and AWS consultant. I currently hold all foreign certifications from AWS and am an AWS community builder. I'm also an instructor and author, currently writing the Azure AI Engineer Associate Study Guide. Have been an international speaker and at over 50 events and conferences. I'm currently the organizer of the Melbourne Python Meetup, and I enjoy all things AWS, open source, generative AI, and virtual reality. So let's go a bit into the agenda. We'll be covering 5 main items today. First, we'll understand a bit more about Fyne and Go. Essentially, understanding a bit more about how Fyne is used within Go. Then, we'll talk a bit about designing and coding up the dashboard. So essentially, gaining a bit more understanding about how we would like to design the dashboard in such a way that we could make it the way we intended it to for the purposes of our particular session, of course. And third, we'll then talk a bit more about styling the dashboard so that we can make it, well, like a professional dashboard. Fourth, we'll talk a bit more about the data handling aspects. And finally, we'll talk about the key takeaways from the talk. So, to start off with, let's have a bit of more understanding Fyne and Go. So, Fyne leverages Go's concurrency model. So, essentially, it should come as no surprise considering that we're all Fyne practitioners already, but pretty much it leverages it, and essentially, this is a simple function-based approach for building UI. So as you can see over there, like we can pretty much just spin up a simple hello world and just essentially create a my window that way. So we can pretty much get the window to show up and run it. And this is essentially what we will be building on today. This is the foundations of what we'll be building on. And why Fyne in particular for data dashboards? Well, firstly, it's lightweight. Fyne apps are performant and resource efficient. It's customizable. There are different components that we can easily put in and accordingly adjust based on our requirements. So this could be from widgets, from sliders, a lot. We can easily adapt these UI elements for our specific needs. It's cross-platform. We can develop once and essentially run on any platform, which is a very versatile way of being able to interoperate with many different platforms that oftentimes we don't see, and which this is why it is a very powerful solution. Designing a dashboard itself has the goal of having the real-time data visualization with the user interaction. It's all about how we can essentially have users view the data in real time and interact with the data. That is something that oftentimes a lot of different consumers search for such a data solution, and it's not always the most straightforward way. So we can actually achieve this with Fyne, and we can achieve this with very minimal components. And this could be in this particular case, charts, sliders, checkboxes, and buttons. So nothing too much. It's pretty much still all visual elements that are already pre-prepped by Fyne. And what we can then do is we can integrate it with live data for continuous updates. Now, the live data that I'll be demonstrating today is going to be taken based on some sensors that I have placed on AWS. So essentially taking live IoT data based on some environmental sensors that I placed around measuring temperature and some other parameters and seeing it fed into the dashboard created by Fyne. So code for setting up the UI itself is very simple. We use container.newVbox for the vertical layout, and we use the widget new label for the headers, which you can see applied there. So you can see for the header, we're applying the new label real-time data dashboard, And for the granularity label, we're pretty much just adding in a label of granularity 1 minute. And of course, this is going to be adjustable later on. We're going to allow it to be adjustable based on the granularity because, as you know, with dashboards, we sometimes can adjust granularity to be able to have the dashboard zoom in on certain elements. For instance, may be 1 minute or 5 minutes or 1 hour, depending on how much you want to zoom in into the granularity of the data. And this is often a very important aspect of development of such things. We can then start to look into the chart creation itself. So we can see that all of this stems from some simple lines of code, starting from the Canvas package, of course, and use it to create some sample custom charts. So we use Canvas new line in particular to create the lines for the axis. And you can see over there that we're starting not just declaring the y-axis and putting in canvas.newline. We're making it black. And accordingly, we're defining positions, position 1, position 2, so we can draw the line through. We then follow a similar approach for the x-axis creation. We more or less want to create a bit of a grid lines as well as part of this. So we can see there that we're basically just declaring the new line with a grid line with the new line from the canvas and pretty much coloring it appropriately with the appropriate RGBA values. And from there, we're pretty much just declaring a new position as well for the grid lines so that they're essentially able to be established upon the specific visualization. And we'll see that later as well implemented when we get to the demo section. We can then look at handling the user input. And this is where things get a bit interesting because we want to make it customizable, as I mentioned earlier. We want to be able to have the user try out different views, different zoom ins and zoom outs. So for that, we're pretty much implementing the granularity slider. So we create a new slider. We then start to implement if on change, then we start to have the value also change. So we then start to look at changing the granularity to be a matter of minutes. And essentially, by you scrolling it, it'll change based on the number of minutes you want from here. We can then start looking at generating live data. Now, this is where things get even interesting, even more interesting. So we want to start off by simulating live data with Go routines. And this is pretty much starting to see how it can swallow sample data. Now, I'm pretty much showing this in case you don't have a sensor handy or you currently don't really have a, well, like a Raspberry Pi or something like that handy that can pretty much help to control the recording of real environmental data. When real data is an issue to be collected, then of course, synthetic data is always the next best alternative. So for this, it's great to pretty much be able to also do this through a simple Go function. So as you can see over here, I am putting in a routine and pretty much just doing a bit of a for over there, which basically just continually generates data with specific timestamps because when we sort granularity and we want to record what time the data point was received at, we need a timestamp. So accordingly, we put timestamp.now, we put in the value and basically just make it fluctuate a bit over 100 plus a certain amount. And in this case, we're simulating temperature. So we can see that's why it has a bit of a value over 100, which is in Fahrenheit. So yeah, pretty much normal temperature. And we're just putting in a specific time to sleep. So it shows how often the data points is generated and how it'll be visualized later on as well in the dashboards and the graphs that we create. And this will be continuously updated on the graph, as you will see as well later on. It's a very important thing for us to be able to show this update continuously because oftentimes when we look at, for instance, environmental data, it's very easy to forget that a lot of these factors can really impact decision making, whether it be receiving data 5 minutes later, 5 minutes. Well, it's always very important to be able to process this data quickly and really get the most insights out of this to be able to make decisions quickly. Of course, we also need to be able to refresh the chart regularly to reflect new data points. And this is also a bit of a trade-off, I would say, because it also depends on how often you want the data to be refreshed. And we can use the canvas.refresh to be able to do this. So we refresh the chart container for a few different purposes. Firstly, for when the chart is currently refreshing to get new values. So when we get new values, we need to refresh the chart to be able to reflect this and to be able to also reset the chart should there be different granularities or something or a different kind of filter applied as well, because we want to be able to display the data points at that particular granularity or filter. So this is where canvas.refresh goes in. And this is where we need to understand, well, okay, how often do we need to refresh it? What cases would refresh essentially break the particular chart? So these are considerations that I have had to take into consideration while building this dashboard as well. For data handling and scaling, it was also a bit of a interesting part, I would say. So we need to understand how data can be added in incrementally and also appropriately scroll to. So essentially, what we want to do is that we want to be able to have the data continuously be added, but we have to be careful that the data that has been in the past is essentially not removed. So that was another challenge that I faced as well originally, to be able to maintain the state. And what we want to then do is that we want to append the specific points. So basically, we're appropriately appending the points based on the specific measurements that we are getting. So we're getting, for X, we're appending by new X plus 50, and Y, we are basically just getting 300, which is basically the dimensions of the particular box minus the data value. So this way, we are basically plotting in the points, and we are also scaling based on how far apart points should appear on the x-axis. So scaling is another important thing because we don't want text to overlap with each other, as I also experienced as well when I was looking at how the x-axis overlaps, values overlaps with one another. And it really is important to be able to consider this in hindsight, and especially because you don't want this to be a problem later on. You can then look at adding the X and Y axes, as I mentioned before. So as part of that, we are adding in the X label, as you can see there. So we're pretty much just putting the time formatting first. We're putting how the time will be formatted. We're coloring it with black and appropriately putting the text size. We are then moving the X label as well based on how it's currently plotted based on point X. So it's a great way of being able to more or less give a judgment of how far apart they are and how much do we want to move the X label. And they really are able to give contexted data points, because if we don't have the specific labels, we won't know what axis is supposed to be for what. And dynamic axis can really update with new points or timestamps, as we will also see in the demo in a bit. They're really able to show you how you can continuously create different views, different perspectives of the graph, and also see how it is portrayed within different granularity levels. Grid lines and markers are another big point, since we can appropriately also allow users to toggle grid lines and markers on and off. And this is more or less a quality of life kind of aspect. because sometimes people might not want to see grid lines or markers. Sometimes people might want to. So I added that thing as pretty much a quality of life. So it really depends on a specific user and how they feel they enjoy it. But essentially, some people enjoy it, some people don't. So it's really helping to enhance the readability or in some, but they might clutter the UI, and that's why we're introducing them. So we can add them in through another widget and pretty much just have it as a new check and appropriately have a function called, yeah, toggle grid lines, which toggles the grid lines on and off, similar as well for markers. So it's a great way of providing this aspect of customizability to the user, which oftentimes is going to be a big thing because we need to make sure that they are satisfied with how it looks and that it doesn't clutter the UI. And of course, as I mentioned before, continuing on from our point on resetting the chart itself, it's always going to be an important thing. We want to ensure that when we do reset the chart, we want to ensure that we reset it at the proper time and at the proper way. So this is a sample of how I'm currently defining the reset chart function. So particularly, we're basically clearing the points array and refreshing the chart and repopulating it accordingly. So we can see here that we are pretty much just getting the point array cleared, and appropriately we're running the refresh chart, and from there we get the points populated again. And like I was mentioning, it's a bit of a trade-off because we need to make sure that it's refreshed only when it's really necessary, especially when points are going to be refreshed, brought in, different zoom in levels. Zoom in is one thing that is certainly a bit more difficult to implement without re-rendering it, at least within this current case. So in this case, we're refreshing it, and so we're starting fresh essentially based on this. And what we don't want to do is that we want to integrate the real-time data feeds. And you can see over here that we are fetching live data from APIs via AWS IoT. So what we want to do is, I'm not gonna go in depth about the code itself for fetching the live data because, well, I want to focus more on the creation of the dashboard and the graphs itself. But essentially, you can see that we are creating 4 different containers. So this is essentially showing the creation of a dashboard. We have a create chart function, which, as it says, it creates the chart. It creates so far based on everything we've defined, and it goes through a different data channel for each one. So each one has different sets of data fed into it. So in my case, I have 4 types of data. I have temperature, pressure, PM 2.5, which is particulate matter 2.5, and also altitude. So these 4 parameters are what I was measuring with the dashboard. And in particular, I used Go routines to continuously and asynchronously fetch the data and update the UI. And appropriately, I created the 4 different charts for the dashboard. So as you can see, we have a degree of separation that is made here, which really helps with being able to keep track of each of the states that's currently put through into as part of each of the containers and have them reflected on the charts, which is a great way of making sure that everything is keeping up on track. And when it comes to styling the dashboard, we can use Fyne styling options, which includes the different colors, fonts, and layouts. And you've seen it being applied as well to some of the elements already, applying it with, for instance, colors like black. And what we want to do is we can also use custom colors for the different chart elements, whether it be axis, points, markers. It's a pretty simple thing. It's in hindsight, but it's something that to keep in mind. It's best practice to always, when you go on dashboards, keep track of these things. Make sure that you are putting different colors for different legends so that everything is clear and people know what is what. And it's always an important consideration when looking at it. It's something that oftentimes we don't take enough care in, especially in terms of making sure that it is understandable for all users, but it's certainly something that we should be doing more. And now I'd just like to show a bit of a demo. For this one, I'll be zooming in to one of the particular charts. So this pretty much will show a bit of a demo on how the different timestamps is reflected. And as you can see over here, we are pretty much receiving data from AWS IoT and pretty much having it reflected in real time. And you can see how it is pretty much plotting the lines and pretty much the graph in real time. And you can see all the different timestamps being tracked. And you can see over as well over there that there is the granularity slider, as you can see here, and also, of course, the check boxes, which you can check and uncheck for showing the grid lines and the show markers. For simplicity purposes, I'll be showing only one of them since I have been trying to focus as well on creating one particular aspect of this. And you can see pretty much that it is receiving the appropriate temperature that way. So, few key takeaways. Fyne is a really powerful tool for GUI development in Go. Real-time data visualization really is able to enhance decision making by a lot. You're really able to get a lot of insights from real-time data visualization, and with the emergence of AI as well at this point, you can automate a lot of this. You can get the visualization automated and pretty much have a lot of insights fed into it. Because just imagine you have the real-time data visualization, you have real-time insights by automating your data visualization insights. So it's really a powerful tool to be able to make decisions quickly, and it's really going to be a big player in the future and now. And custom components are going to be key. It's important that you design your visualizations with much customization depending on your requirements, of course. It really depends on how your target audience, how much you need to customize it, what features you want. But essentially, that's what will separate how you customize it in Fyne compared to how other players are. And that's one of the things that I really like about Fyne, because you get this customization, you get these elements that you can really use to tailor what you have towards the specific needs of the project. Concurrency in Go really is able to ensure performance, as you have seen over in the demo and more, and as we have also talked about. Aside from that, user-friendly dashboards always require flexibility. You always need that degree of flexibility to ensure that what you are putting through can essentially cater towards different flexible requirements by people. People might look at inserting different values, look at inserting values that might not easily be displayed by dashboards or similar kinds of considerations. So it's always an important thing. And when we design these kinds of aspects, we always need to keep in mind that these are things that we need to be cautious of and be mindful of and ensure that we can provide the best performance that way. And with that, thank you for attending my talk. Unfortunately, I can't be there directly to answer questions, but I'm always happy to answer questions regardless, so please do feel free to send questions my way. You can see all my socials there, my Twitter/X, my LinkedIn. You can connect with me in any of my socials, and feel free to reach out to me. I'm always happy to take any questions. And with that, thank you again, and I hope you have a great rest of the day at the conference.